The first example we're going to look at today is very similar to a question that you would have seen 2 days ago, but this is with radian measure instead of with degree measure. So it's just getting you used to thinking in terms of radians. Find the exact value for sine of negative 13 pi by 6. So what this means, you can't put it in your calculator. Okay? If it was find the value of sine negative 13 pi by 6 to 2 decimal places, then you would just make sure your calculator was in radian mode, and you would do the sine of, and you type in negative 13 times pi divided by 6, hit enter, and you'd have the answer. But because I want exact value, it's a little more complex. Okay? And you can do it without a calculator, and it could be a calculator, non-calculator question. First job, find the quadrant. Which quadrant is negative 13 pi by 6? So we think about our quadrants. We label quadrant 4. Okay, so we've got some in quadrant 4, some in quadrant 1. Let's see where it ends up. We've got 0, we've got 3 pi by 6, we have 6 pi by 6, we have 12 pi by 6, down here we have 9 pi by 6, so it's the same as the last example. And we want to go in the clockwise direction because we're doing negative, and we want to go negative 12 and 13. So yeah, we're in the fourth quadrant. Okay? So we're down here in the fourth quadrant. Okay? Yes? Yes. Then, what is the reference angle here? So we went all the way around 12 pi by 6, and then one more pi by 6 to get to negative 13 pi by 6. So the reference angle is pi by 6. Okay? Now you aren't necessarily thinking about this in terms of a special angle, but this is one of your special angles from one of your special triangles. You are used to your special triangles in degrees, but you're going to have to start thinking about them in terms of radians. So if we have this one, this is 30 degrees and this is 60 degrees. However, what is 30 degrees in terms of pi? In terms of radians? You have it on the front of your sheet. 30 degrees is pi by 6. And 60 degrees is pi by 3. So you will have to start thinking in terms of that on your special triangles. The other special triangle, which was 45, 45, what's 45 in radians? Pi over 4. Okay, so those are your special triangles with radian measure. So we want the sine of negative 13 pi by 6. So we're first going to think, well, what's the sine of pi by 6 then? The sine of pi by 6 is 1 over 2. So the sine of negative 13 pi by 6, which just means in the fourth quadrant, sine is negative. So that would be our final answer. Okay? Questions about that? We're okay with that? Okay, so let's try another one. How far can I scroll it? Oh, it's going to be gone, sorry. So here's an example. I have a point, negative 4, 3. It defines angle theta in standard position, and your job is to find all possible values of theta between negative 2 pi and 2 pi and round them to the 10th of a radian. So we're going to have these in terms of, we're going to have them rounded off, not in terms of pi. Okay? So I've got negative 4, 3 plotted on the coordinate plane. So it's defining a reference angle in the second quadrant. and theta is here. Okay. How am I going to figure out what theta is? How would I figure it out if it was in degrees? What would I do? Any ideas? Yeah.
You'd find the reference angle and subtract it from 180.
Yeah, and how would I find the reference angle?
You could probably tan would be easiest, just because you don't have hypotenuse then.
So tan of the reference angle, so let's write reference angle instead of theta. Tan of the reference angle is going to be 3/4, right? Opposite over adjacent. So to find the reference angle, we're going to do the inverse tan of 3/4. Okay? Now, what mode should you put your calculator in? Degree mode? But don't you want your angle in radians? Now, you can put it in degree mode and then change everything later. But why not just put it into radian mode right off the bat? So if you put it in radian mode and you do the inverse tan of 3/4, what do you get for your reference angle in radians? Anybody who's done it? I know, Colin, you're doing it, right? What do you get? Sorry, again? 0.644. Okay? So it's 0.644 radians is right here. So what is theta? This angle here. How are we going to figure that out? Yep. Pi minus that, because this is pi here. So if we take pi and subtract 0.644, we're going to get theta. So pi minus 0.644 gives me 2.49. Okay? Now notice the star up here, and we want to the 10th of a radian, so we can just round that off to be 2.5. Does that round to be 2.5, or was the 9?
It's 2.4900.
Yeah, so 2.5, okay. I forget that I was going to ask that question. So yeah, 2.5. Now this says that I want the answer to be between negative 2 pi and 2 pi. So I have the answer that's between 0 and 2 pi. How do I go back the other way to get between 0 and negative 2 pi? What am I going to do? Subtract what? 360 degrees, which is how many radians? 2 pi radians. So 2.5 take away 2 pi is going to take me back the other way. And what does that work out to be? Negative 3.78. So it's 3.8 to the nearest tenth. Okay, so those are my two values of theta between negative 2 pi and 2 pi. Okay. Questions about that? Okay, another one. Last one, I think. Oh, yeah, this will be the last one. Okay? So we've done a question very similar to this one on Monday, but it was with, I think, secant. Cotan theta is equal to negative 2. Find all possible angles between negative 2 pi and 2 pi to the nearest tenth of a radian. Okay? So whenever it says tenth of a radian, it says we're not worried about exact values. You're not going to use your special triangles. You're going to use your calculator, but you're going to find all possible angles. Okay? So what is cotan theta equals negative 2? What does that tell me? What's the first thing you think of when you see cotan? Tan, right? So if cotan theta is negative 2, then tan theta is? Negative 1 over 2. Okay? And if tan is negative, which quadrants are we talking about? 2 and 4. Good. So we're in quadrant 2 and quadrant 4. Okay? What is the reference angle? They have the same reference angle, but what is it? How do we find it? Same way as we found the last reference angle. We're going to do inverse tan, but just of the positive value. You're going to ignore the negative because it does lead to some confusing answers. It won't give you necessarily the reference angle. It will give you something with the same reference angle. So the inverse tan of a half in radians is what? Sorry, pardon me? I think you're in degree mode.
Oh, yeah.
Change yourself into radian mode. And then what do we get? Somebody with it in radian mode? Jamie, did you do it? 0.46. Okay, so we've got 0.46 as our reference angle. So now we need to know what is this angle here and what is this angle here. So how am I going to come up with the second quadrant and the fourth quadrant angle? Yes?
It was negative 1 divided by 2, right?
It was, but if you put negative 1 divided by 2 in there, you're not going to get 0.46, but you're going to get something with that same reference angle. Okay? Put in second tan of negative 0.5. Okay, so that puts you here in this fourth quadrant, and it's giving you that reference angle of 0.46, but it's still not giving you that final answer. Okay? And so for tan, it's not a problem, but sometimes for cosine and sine, it can be confusing. So if we just ignore the negative, then we know we're getting the first quadrant reference angle, so positive reference angle. Okay, so to get this angle here, we're going to take the 180, or pi, take away 0.46. And to get this angle here, we're going to do 2 pi, take away 0.46. Because we want all the way around is 2 pi, and then we want to take away that reference angle to get the angle we want. So what's pi take away 0.46? Anna, did you calculate that one? 2.68. So 2.7, right, if we're rounding to the nearest tenth. And then 2 pi take away 0.46. What is that one? Colin Borelli?
5.82.
Sorry?
5.82.
5, and so I'll just go 5.8 for that. Okay? Now again, those are my answers between 0 and 2 pi, but I want from negative 2 pi to 2 pi. So I need to do what to these answers to get the other two answers?
Make them negative.
Nope. Actually, I think that does work. But really what we want to do is subtract 2 pi. So 2.7 subtract 2 pi and 5.8 subtract 2 pi. What do you get? Is it just the negative of those? Nope. Negative 0.46, so negative 0.5. And what's 2.7 minus 2 pi? 9.0. Negative though? I don't think it would be. 2.7 minus 2 pi. I think you... Negative 3.58. So negative 3.6. Okay? So those are the 4 solutions in that domain. Okay? Are we all right with that? Okay, so it's going to take some practice, which means